Okay, so here, suppose it is asked to uh, find the solution of the differential equation, which is dy by dx equals to f of some x comma y. So the rule is that if the function f of x comma y can be written in the form of lambda, um, means f of lambda x comma lambda y, means if we replace this x with lambda x and if you replace y with lambda y, then if the function f of lambda x and comma lambda y, that can be written as lambda power n into f of x comma y, then the function then the function f of x comma y is called a homogeneous function of degree n, is called as a homogeneous function of degree n. uh, and then and if f of lambda x comma lambda y, that is equal to lambda power 0 f of x comma y, then the function then the function f of x comma y is called a it's called a homogeneous function of degree 0, homogeneous function of degree 0, and this differential equation will be called as uh, a homogeneous differential equation. And then this differential equation this differential equation will be called as this differential equation will be called as a homogeneous differential equation. And how it can be solved, here we have to take y equals to some v of x, and then we will get dy by dx will be equal to v plus x dv by dx. And then we can solve this type of homogeneous differential equation. Suppose, for example, if it is asked to solve the differential equation, that is, it is told that show that the differential equation x cos y by x into dy by dx, that is equals to y cos y by x plus x, is a homogeneous differential equation. It is a homogeneous differential equation, and then its general solution. Find its general solution. So here, as we can see that it is having order 1. So in the general solution also, it will have only one arbitrary constant. So here dy by dx, we can write it as, it will be y cos y by x plus x divided by x cos y by x. So hence it is a differential equation. Hence it is a differential equation of the form of the form dy by dx equals to some function of x comma y. So here if we replace, x with lambda x and y with lambda y, then we will get uh, so this function of x f of x comma y is nothing but y cos y by x plus x divided by x cos y by x. So here if we replace x with lambda x and y with lambda y, then we will get f of lambda x comma lambda y, that will be equal to lambda y into cos lambda y by lambda x plus x plus this is lambda x also, and this will be lambda x into cos lambda y by lambda x. So lambda and lambda will cancel. From here also I can take lambda as common. This will be y cos y by x plus x divided by lambda into x cos y by x. So lambda and lambda will cancel, which is coming same as f of x comma y into lambda power 0 obviously. So it is a so f of x comma y here in this case is a homogeneous it is a homogeneous function. The homogeneous function of degree 0 of degree 0. So the given differential equation, is a homogeneous differential equation. So here we can put y equals to v of x, v into x. So then dy by dx, that will be equal to x dv by dx plus v plus x dv by dx. Now therefore is v plus x dv by dx, that is equal to so y we can write it as vx, so this will be vx into cos, so y by x will be obviously v, so cos v plus x divided by this will be x cos v. So from here also x we can take it as common, and this will become x cos v plus 1 by cos v. Okay, so then therefore we can write it as x dv by dx, so that will be equal to v cos v plus 1 y cos v minus v. Yeah. So then you can write this as x dv by dx, so that will be equal to v cos v plus 1 minus v cos v divided by cos v. So v cos v it will cancel out. So then we can write it as cos v dv, that is equal to dx by x, and then we can integrate both sides. So integral of cos v, it is sine v that, and then integral of dx by x, that is equal to log mod x plus, we can write it as log c also, log mod c. Okay, so then so therefore sine v we can write it as log mod c x, and then v we can write it as y by x. So therefore we can write this as sine y by x, that is equal to log mod cx. So this is the required general solution of the given differential equation. So this is the final answer. Then we can solve one more example based on this concept. Suppose it is asked to show that the differential equation 2y e power x by y into dx plus y minus 2x into e power x by y into dy, that is equal to 0, is a homogeneous differential equation. Is a homogeneous differential equation, and then find its particular solution. Find its particular solution given that x equal to 0 when y is equal to 1. Okay. So in this differential equation also we can write it as dy into, so this is y minus 2x e power x by y, or x by y, that is written, that is equal to, we can write it as minus 2y e power x by y into dx. So then this can be written as dx by dy, that is equal to 2x e power x by y minus y divided by 2y e power x by y. So this we can write also as f of x comma y. So then if we replace x with lambda x, and if you replace y with lambda y, then the function of f of lambda x comma lambda y, that will be equal to 2 lambda x e power lambda x by lambda y minus lambda y divided by, this is 2 lambda y e power lambda x divided by lambda y. So this will, so the lambda will cancel out here, and from here also we can cancel out lambda by taking common in the numerator. So that will be also equal to 2x e power x by y minus y by 2y e power x by y. So which is same as f of x comma y into lambda power 0, we can say. So hence we can say, hence the function f of x comma y is a homogeneous function of degree 0, homogeneous function of degree 0. So the given differential equation is a homogeneous differential equation. So the given differential equation is homogeneous. So the given differential equation is homogeneous. And then, so here it is in the reverse case, means here it was dy by dx, but here it is dx by dy. So here we should replace, here we should put x equals to vy instead of y equals to vx. We should put here x equals to vy. So then dx by dy, that will be nothing but v plus y dv by dy. So that will be equal to this function. So x will be vy. So we can write this is vy to vy e power. This is, so x by y will be v, obviously. So x by y, that will be v. So then so this is e power v minus, this is y, and divided by, this is 2y e power v. Okay. So now here also we can take y as common, and this will become 2v e power v minus 1 by 2y e power v. So y and y will cancel out. Therefore, we are getting it as v plus y dv by dy, that is equals to 2v e power v minus 1 by 2 e power v. So then we can take this v on the right hand side. That will, then we will get y dv by dy, that will be equal to 2v e power v minus 1 by 2 e power v minus v. Okay, so then we can take the LCM. So that will be y dv by dy. That will be equal to 2v e power v minus 1 minus 2v e power v divided by 2 e power v. So then these two will get cancelled, and then we will get 2 e power v dv. That will be, then it will be, here minus 1 is there, so this will be minus dy by y. Then we can integrate both sides. Then integral e power v is e power v only, and this will be minus log mod y plus c, we can write. So then we can replace it with x by y. So that will be 2 e power x by y, and plus we can write plus log mod y, that is equals to constant c. So this is the general solution of this given differential equation, but we need the particular solution where the condition is given that x equals to 0 when y equal to 1. So x equal to 0 when y equal to 1. So this we have to put, and then we can find the value of this arbitrary constant. So x equal to 0. So therefore we will get 2 um, 2 e power 0 plus it is log mod 1, that will be equal to c. So log mod 1 is 0 only, and e power 0 is also 1. So c equal to 2. So hence we can say the required particular solution, of this differential equation is um, 2 e power x by y plus log mod y, that is equal to 2. So this is the answer. Thank you.